All right, everybody, welcome back for section 2.2. And this one's going to be quick, I promise. In section 2.2, we're going to take a look at the histogram. What a histogram is, how they look, what they look like, what we use them for, that kind of stuff. So the key concept in this section is that frequency distribution from section 2.1, it's good, but a better tool is a histogram, which is a graph of that frequency distribution. And sometimes graphs, pictures, are easier to interpret than tables. Really getting good at being fluent at interpreting a table of values, the frequency distribution, takes time. It takes a skill to be able to look at those things and interpret them well. Whereas a histogram takes a lot less skill. So a histogram is a graph. It is a bar graph, where bar graphs will have equal widths. The equal widths will represent the class width. The bars touch unless there are gaps in the data. Okay. The horizontal scale is going to be those classes, that quantitative data values. The vertical scale represents those frequencies. So if we were to take that information from McDonald's service times and turn that into a frequency, into a frequency histogram, it would look like this guy in red right here. So across the horizontal, we have the service time measured in seconds. Across or up the vertical, we have the frequency, and then the bars are representing those frequencies. So back up here, when we looked at that a long time ago, 13, 23, 9, 3, 2, 13, 23, 9, 3, and 2. Those are our frequencies here. So the bar heights represent those frequencies. Now, one thing that is interesting is these numbers right here. Where did those numbers come from? Because if I remember correctly, back up here, the class widths were 83 to 128 for that first class. Down here, where are they getting these numbers from? Okay, well, first off, they used a different frequency distribution than we did. They must have made one with different number of classes. And these values, this 74.5, this 124.5, this 174.5, what those represent are something called the class boundaries. So if a class went from 1 to 5, we would say that the 1 is the lower class limit, the 5 is the upper class limit, but 0.5 and 5.5 would be the class boundaries. Class boundaries are always half a unit below or half a unit above, depending on whether you're talking about the low end or the high end of a class. So this 74.5 right here tells me that their first class started at 75. This 124.5 right here tells me that their first class ended at 124. Now the 174.5 right here means that the second class went from 125 to 174. And the third class, and so on and so forth. So you can read the classes off of that. Now, the reason for this is because of the way class boundaries are. If my first class went from 75 to 124, and my second class was 125 to 174, and I wanted this bar to represent the first class and this bar to represent the second class, what number is that splits them? I can't use 124 because that goes in the first, and I can't use 125, so we split the difference, and we call that what's right in the middle between that upper and lower. So again, those numbers across that horizontal axis there, those are the class boundaries. So if we went back up here and found the class boundaries for our frequency distribution, this would be 82.5 and then 128.5, and then 174.5, and so on and so forth. Splitting the difference between those. Right? Now they have different uses in graphing things. That's the major use for class boundaries, especially histograms. We like to use histograms. The other way that we can label that horizontal axis, if you don't like class boundaries, is you could label the middle of each of these, and you would label the middle of each of these by finding the midpoint of each class. So the class midpoints. Now the class midpoints are nice because there's actually a formula for that. It's the lower class limit plus the upper class limit divided by 2. So for example, for the first class, since it goes from 74 to 124, we would say, I'm sorry, 75 to 124, we would say 75 plus 124 divided by 2. And that looks like calculator work to me. So 75 plus 124, divide that answer by 2, and I get 9. So this one we would label right here in the middle as 99.5. And then to find the next one, we would take 125 plus 174 and divide that by 2 to get our second middle, or the midpoint for that class. Right? All right, so what do we use a histogram for? I want to visually display my frequency distribution. I want to make a picture. And with a picture, I can more quickly see, here's all the data. It's right there. This is small. Maybe I could add that third one in out to there. But basically, I'm looking at 224.5 and down. That's where the data is. Everything bigger than that, all of this stuff out here, nobody cares. Because the frequencies are so small, it rarely happens. Here's where most people live. And that's the whole purpose of this. I just want to be able to see that. Right? So it shows the location of the center. It shows how the data is spread out. Right side is really spread out. Left side is not spread out. It can also help us identify outliers. It can also help us identify when data is an outlier, either too small or too big, and it shouldn't be there. Okay? Now, a relative frequency distribution or a relative frequency histogram just says, well, how about instead of frequencies, we put relative frequencies over there. So instead of 5, that's going to be 10%, and 10 will be 20%, and 30%. So we're just relabeling 40%. That vertical axis, instead of a raw number count, percents. And why would you do that? I don't know, because you could. That's basically why you would do it. Maybe that's the story you want to tell. Again, there's no right way to do this. There's just ways to do this. There are some things that you have to do. We label the horizontal axis with boundaries or with midpoints. The bars touch. Those are halftas. Whether you call this frequencies or relative frequencies, that's up to you. Okay? You make sure you put labels on the axes and a title on the graph. Those are halftas. Okay? But the color that you choose, whether you call these percents or counts and make it a frequency or a relative frequency, that's totally up to you. Right? When we're interpreting these, when we're thinking about these histograms, what we want to do is we want to think about those things that they tell us. Where's the center? Oops, I wanted a highlighter there. Where's the center of the data? Okay. When I look at this, is it centered around something? Does it look like I could balance it somewhere? Okay. What kind of variation are we talking about here? Okay. Is it just smushed all the way across all the same? Does it have a peak? Is it spread out on one side more than the other? What's the shape look like? Are there any outliers? And then the last thing is, how does time come into this? Right? So when I look at this first one, some common distributions, I would say, look, it's kind of bell-shaped. So the middle is right about there, somewhere around 100. Okay? It looks pretty even left and right, so it's pretty symmetric. I don't think there's any outliers because I don't see anything that looks like it's too far away on either side, so it looks pretty good. When I compare that with this one over here, well, this one, everything is about the same. And when everything is about the same, we call that a uniform distribution. I could still find the middle because I could say, it looks like the middle's somewhere about here. Like if I put my finger under there, that's where it would kind of balance. And that's what I'm looking for the middle. It looks like there's a lot of variability because these bars over here are almost as tall as these bars and almost, so everything has the same height. So there's lots of spread and lots of variability. Again, I'm not sure I see outliers though. When I look at this data set down here, we would say that this one is skewed to the right. And what does that mean? Well, if I look at the distribution, there's a peak, and then this right side appears to be longer than the left side. There's more spread, more variability on the high end than on the low end. Now, I could still say, well, I could probably balance it somewhere about there. So that would be about the middle of the data. But there's much more spread on this side, so we're skewed to the right. Still not seeing outliers. Outliers, I'd want to see like a bar sticking up out here, you know? And I'm not seeing that. So I'm still not seeing outliers. But I am seeing a spread to the right. So I'll say that's skewed to the right. And if I flip that, I get skewed to the left, where the left side's too big and the right side's kind of small. Again, I could still find a middle. I could say the middle's about here and it would balance. I could say there's a lot of variability on the low end, little variability on the high end. I'm not seeing any outliers, but I am seeing something pretty and a nice skewed to the left distribution. Right? All right, so I told you this one was going to be quick, 12 minutes per video. That's pretty quick. Histograms. What are they? It's where you take a frequency distribution and turn it into a picture, a graph. Okay? How do you do it? Well, the horizontal axis is going to represent your classes. We normally label it with either boundaries or midpoints. And then the vertical is going to be one of two things almost every single time. It's either going to be the frequencies, the raw frequencies, or it's going to be relative frequencies, almost always as percents. Right? Why do we use them? Because we like to look at pictures. We want to be able to look at it and go, there's the middle, there's the spread, here's what I'm looking at. Right? So all of these distributions right here are considered histograms. And they all represent the data in different ways. They show where the data is, where the data isn't. They show the spread of the data and how it's distributed. Right? We love these guys right here. We love those bell-shaped normal distributions. Those are very, 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 very important to stats. We'll see lots of those. All right, that brings us to the end of section 2.2. Have a great day.